Good day to you all. I'm Shabu Subramanian, signing into the virtual classes of Scientia. Today we are into the other session of electrostatics, where we will be discussing about electric field in detail. So like we have understood the concepts of electric force in the last session of discussion of Coulomb's law, today in this session we are going to see electric field in detail. Like I have given in the first session a screenshot of the entire unit of electrostatics. I hope this picture will be there in your mind, which gives the proper relationship between force and field, which is a vector equation. As I told you, force is equal to charge times electric field, or electric field is force divided by the charge. And the other one is scalar equation, which is relating potential and potential energy. This we'll be seeing in the coming sessions. In the last session of Coulomb's force, we have studied about electric force in detail. So this is our time to study about electric field E in detail. Electric field E, which as I presumed that this is equal to F divided by Q, as I already given you like this. So we are going to see that one in this session. I'm going to wipe off this one. Please all of you keep this one as a screenshot in your mind so that the study will be very easy for you. In the discussion of the Coulomb's law, you have seen two charges kept at a distance, say one is Q1, the other one is Q2. Let this be at a point O, this is at a point P. Distance R, they are interacting, or they are having a force between each other. We have studied about that one in detail. Let me call this charge as Q1 as capital Q, or I'm calling this one as this source. So Q1 is taken as Q, which is acting as a source. So that is producing something. A source, you know that it is always producing something. And Q2, I'm treating that one as small q, or in physical experiment, I'm calling this one as a test charge or the testing unit. So what is the aim of this experiment or the study? We are going to test the source with the help of a test charge. What is the effect of small capital Q at the point P? That is what we are going to study. We all know that if a charge Q is placed here, there will be a force experiencing by that one, that is given as 1 over 4 pi epsilon naught capital Q multiplied by small q divided by r square unit vector. This is the force. We know that if these two are positive, that force will be acting in this line, or that will be a repulsive force acting away. So that's what we already know. Now suppose that if this charge is removed from there, whether there is any effect there or whether there is any force there, it has to be there, correct or not? Because if I'm bringing a charge Q here, it is experiencing a repulsive force. That means this point has got something from this Q. If I place that Q somewhere over here, then also that will experience a repulsive force, correct? If I bring that one slightly closer to this, somewhere over here, then also that will be experiencing something like this. So at any point surrounding the source, a charge Q is experiencing a force. That means the charge Q has got an ability to provide or to produce an electrostatic force in its surroundings. Or that effect or that ability of that charge or that area or that space around Q in which it is producing a force, we can call it as what? Electric field. So what is electric field? It is the space around a charge, any charge, in which another charge is experiencing an electrostatic force, or it is producing an electrostatic force on another charge. So what is electric field? It is the space around a charge in which another charge experiences a force. So how we can make a mathematical expression for that one? The electric field mathematically is defined as the force experienced by a unit charge placed at a particular point. So electric field due to a source charge is defined as the force experienced by h value of unit charge at a particular point. So from this I can find out the electric field as, now the force experienced at the point P when small q is placed is F. So if that is unit charge, how we have to find it? Divide F with Q. The problem is very simple, just like our lower primary classes problem. If 10 mangoes cost F value, what is the cost of 1 mango? This is very similar to that. So if I take that, the expression for field due to a charge will become Q by R square unit vector R. So we can call this one as the electric field produced at the point P due to a point charge capital Q. So that gives the electric field due to a source charge at a particular point P. That is the expression. This is the mathematical expression for electric field. So we can see that electric field is inversely proportional to R square. So that is an inverse square relation. So if we plot electric field versus R, E versus R, it's an inverse square relation. The shape of the graph will be the shape of the graph will be it will be like this. So electric field is proportional to 1 by R square. So we have studied what is electric field due to a point charge. What is electric field due to a point charge? It's a force experienced by a unit positive charge when placed at a point. So electric field due to a point charge at a point is defined as force experienced by a unit charge placed at that point. And the shape of the graph is an inverse square relation. So this much we have learned from this concept. Now let us look into this concept in much detail, or let us try to get some more aspects of this. That we can see that when we have derived the equation E is equal to 1 by 4 pi epsilon 0 Q divided by R square unit vector R, we can say that E is independent of the test charge. It is independent of the test charge. So it does not depend upon the value of small q, or it is independent of the test charge. What is the second equation I can write? We can write F is equal to Q times E. That is the force experienced by a charge Q placed at the point P can be expressed as F is equal to QE, or E can be expressed as F divided by Q. That's the second observation. Now what about the third? Let us see. So we have got a charge Q placed at O, and we have a point P at which we have found the value of the field. Now let me take another point on the left hand side at the same distance R. We can say that at this point, let this be P dash. At that point also the value of the field will be the same. So we can say E at P will be equal to E at P dash. If I choose another point over here with the same distance, so P double dash, at that point also the field will be same. Or if I make a sphere of radius R around the charge Q at any point on this one, at any point on the sphere, the value of E will be the same. So we can say that around Q, if I consider a sphere, on the surface of the sphere at any points the value of electric field will be same. So I can say that electric field has got a spherical symmetry. This is known as spherical symmetry. What is meant by spherical symmetry? You can say that at the point on the surface of the sphere, at any point the value of the electric field is same. Now the other question is, if I place a plus q charge over here, a plus q is experiencing a repulsive force. If this is plus 1, that is also a repulsive force. Or I can say that the electric field due to a positive charge is outward. What about negative charge? Suppose the test charge is not positive. If this is negative, what will happen for the plus 1 coulomb charge? Instead of repulsion, it will experience an attraction. Here also that will be attraction. That will be radially inward. So electric field due to negative charge will be radially inward. These are the important points about electric field which you are studying in the unit. So we can see that the electric field due to a point charge is defined as 1 by 4 pi epsilon 0 q by r square. This is independent of the test charge. This has got the relation F is equal to QE with the force. Electric field has got a spherical symmetry, and electric field due to positive charge is outward and electric field due to negative charge is inward. So that is about electric field, or we can call it as electrostatic force field. So that is a small session on electric field for all of you. I hope all of you must have studied this equation or the vector equation in detail, or you have understood that. Thank you all for watching the session. I am signing off from the virtual class.